Welcome to week number 12, lesson number 1 for our class. And boy, oh boy, we're getting close to the end. Um, we have much to do this week. In fact, you're going to have a quiz and you're going to have a project due this week. So I want to keep the actual lesson time shorter. We're going to go over the homework answers as always, same beginning, to do it, some review work, and then I just want to go over a handful of law of cosines and law of sines problems to make sure everybody understands that well. There will be questions on your, or I should say, there were some on the last quiz, and there'll be questions on this quiz about those two topics as well as on the project. The project will be pretty heavy with it. So I want to make sure you understand that completely. This lesson will be a little bit shorter, and so will the next lesson be a little bit shorter. We're supposed to meet for an average of 4 hours a week. That's what a 4-credit course is. And there's no way that these two videos will take more than, say, an hour and a half between them. So that gives you a lot of time to work on your quiz and your project. Maybe enough time fully. If not, you won't need much more than that. All right, let's see what your homework answers look like. And the last questions? And you know all about stop and start. Okay, here is a problem. One of the most important things, in addition to knowing the laws, probably the critical step is to say, do you understand when to use the law of sines and when to use the law of cosines? And we mentioned the other day that if the information you're given after you draw the diagram is side angle side information, law of cosines. If it's side side side, law of cosines. If it's anything else, then we're going to go with the law of sines. And also remember that big angle A is always across from or opposite side little a. Big angle B is always opposite or across from side little b. And big angle C is always across from or opposite side little c. So in this problem, when it says in triangle ABC, A equals 24, little b is 36, and little c is 30, that means those are the sides because little letters mean sides, line segments. Measure of angle A, that's an angle. Obviously, because it says measure angle, but also because it's a capital A. And it says to the nearest tenth of a degree. So you can do stop and start at this point, and then I'll go through the whole problem for you or with you. Okay. So the first thing I do is draw the diagram, and I want you to notice that little a is 24, and that's opposite or across from big A. Little b is 36, that's across from big B, and little c is 30, that's across from big C. That's how you always draw these diagrams. And then based on this information, it's pretty easy to see that we have side, side, side. So that means law of cosines. And it wants to find the measure of angle A, so we begin with a squared. So remember the law of cosines. It's a squared is b squared plus c squared. It's just the one you're looking for squared is each of the others squared. Add them. Then it's minus 2. This guy, there's the b. This guy, there's the c. And then the cosine of whatever the beginning letter was, in this case, a. And the reason I always say this guy, and the beginning letter is because what if they give you an x, y, and a z? This way you understand the pattern to it. And if you look at any of the forms of this, a squared equals b squared equals c squared equals, you'll find that pattern resumes for all of them. So once again, a squared here, this a is little a is going to match the big A here. And then it's b squared, c squared, the other two letters. And then this guy, that guy, repeat them. And the minus 2. Okay. So I start substituting. Little a is 24, b is 36, c is 30. Minus 2 times 36 times 30 times the cosine of a. Let's do some squaring here. Those are the numbers when they're all squared out. Now, this is where some students make a big mistake, okay? What some students will do is this. They'll combine the 1296 and the 900, which is correct. and then it says minus 2160 cosine A. And some students, let me go back there, will do 2196 minus 2160. You can't do that because they're not both cosine A's. This is like 2196 minus 2160x. They can't be combined. Now, if it was 2196x minus 2160x, then you could combine them and say, yeah, that's 36x. But the way it is now, you need to subtract 2196 from both sides. That gives negative 1620 equals negative 2160 cosine A, dividing. And when you do that division on your calculator, you get that the cosine of A is 0.7500. And then you do second cosine on your calculator, and A is 41.4 degrees. Now, you know you're going to see a question like this on your project somewhere. And you know you'll see one on your final exam somewhere. And you will probably see something related to this on your quiz coming up. So I would suggest strongly that if you did not get this correct, you go back to the beginning and try this question again. Okay? Now, just a quick reminder of trigonometric ratios. We did sine, cosine, tangent, right? And we had that expression SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also had cosecant, secant, and cotangent. Cosecant's the reciprocal of the tangent, of the sine, sorry. Secant's the reciprocal of the cosine, and cotangent's the reciprocal of the tangent. So, for this problem, let's label the sine, cosine, tangent, cotangent, secant, and cosecant of x. Go ahead. That's my dog snoring. Okay. Now, the sine is opposite over hypotenuse, so that would be the opposite is 8, the hypotenuse is 17. The cosine is adjacent over hypotenuse, that makes 15 over 17. The tangent is the opposite over adjacent, which makes 8/15. Now, the cotangent is the reciprocal of the tangent. Ooh, that should say 15/8. Let's do a correction here. I can't believe I messed that up. Sometimes I do these fairly late at night, and I just make sloppy mistakes, careless mistakes. It happens. This morning, my wife had dog training, and I accompanied her to watch her train the dogs, and I'm kind of tired. So I think sometimes that contributes to careless mistakes. Okay, so sine, cosine, tangent. The cotangent is the reciprocal of the tangent, which would be 15/8. Secant is reciprocal from cosine. Remember, we pair them up from the inside 2 out. That's 17/15, and the cosecant would be 17/8. And here's your pairings. From the inside out, those are the reciprocals of each other. As long as you remember the order that everybody learns them in, sine, cosine, tangent, and then cotangent, secant, cosecant, right? Sine, cosine, tangent, cotangent, secant, cosecant. There's the cosine and the secant are reciprocals, and the sine and the cosecant. Okay. Try this guy. Go ahead. Okay. Now, we have an isosceles triangle, and the two equal legs, here they are over here, they meet at an angle of 43 degrees. If that's 43 degrees, when I subtract that from 180, I get 137. And then, because this is an isosceles triangle, both base angles are equal, so that means they're both going to be 68.5, half of the 137. So as I put out this diagram, what I see is my information is not side angle side, and my information is not side side side. So I go with the law of sines. And that says the sine of A is to A as the sine of B is to B, and so on. And remember, they're across from each other. So sine of 43 is to 673, as the sine of 68.5 is to x. Let's find the values. I substitute them in. I cross multiply. 0.6820x equals, and then 0.9304 times 673 is 626.17. I divide by 0.6820, and I get x is 918. So the length of a leg of the isosceles triangle, remember the legs make up the vertical angles, they're across from the base angles, is 918. Okay, try this one. A little tricky with this diagram here. Keep in mind, if I want to find this whole angle here, it's made up of this 15-degree part and the 90-degree part there. And that this angle over here has to be 90 degrees because of the 90 there. So that'll help you find the angles inside that triangle. Go ahead. Okay. Now, that makes this angle 105 degrees and this guy 43 degrees. I'm going to have to find two sides here because it says the distance the fire is from both station A and station B. So that's two things I need to find. The fire is up here, F. So I need to find the Y that goes from station A to F and the X that goes from station B to F. F has to be 32 degrees because the three angles of a triangle add up to 180 degrees. So in order to find X, I'm going to do the law of sines, which is easier than the law of cosines. And I get the sine of 32 is to its opposite side, 100, as the sine of 43 is to its opposite side, x. Look up the values, cross multiply, divide by 0.5299, and I get x is 128.7. Now, at this point, to find y, I could use either the law of cosines or the law of sines. I'm going to do cosines just to give you the practice. There's y. It's going to be 128.7 squared, that's over here, plus 100 squared, which is here, minus 2 times 128.7, this guy, that guy, 100, and then the cosine of that angle in between, which is 105. So y squared is, I just do the squarings, okay? And I also multiply this out because I can find the cosine of 105, okay? Adding all of them up, 18,315. Notice, something we learned the very first day of class, you can only add or subtract things that are alike. In the previous problem, you couldn't add or subtract the problem that had cosine at the end of it because cosine of A was a variable. It was its own unique thing and it couldn't be combined with previous terms. But in this case, all three terms are numbers, so they can be combined. So y squared is 18,315, square root both sides. Y is 135.3. Okay, and that makes sense, right? Because the longest side is across from the biggest angle. The medium side's across from the medium angle, and the smallest side's across from the smallest angle. All right. Let's try this one. Go ahead. Remember to ask yourself, is your information side angle side or is your information side side side? If so, we go law of cosines. If it's anything else, we go law of sines. Good. All right. So let's see how you did on this guy. First, I have to draw the line that connects the maple and the oak tree because it wants to know how many yards apart are the two trees. I'm going to call that y. And that gives me y squared equals, it's y squared equals, it's the law of cosines because we have side, angle, side. 50 squared plus 30 squared minus 2, this guy, that guy, cosine of 120. So y squared is 2500 plus 900 plus 1500. Y squared is 4900. Y is 70. Choice 3. Okay, try this guy. Try the couple of marks on there actually where I started to draw the diagram. But go ahead, give it a shot. A little tricky to draw the diagram. I think if you draw the diagram, the law of sines, law of cosines work is not so hard. But you got to get that diagram done. Go ahead. Okay. So, there's my diagram. This is airport, and that's C. A is for airplane A, B is for airplane B. C, I put APT next to it because it's short for airport. The angle, where are we here? The angle of A is 50 degrees to the left of B. So here's B, so that has to be 50 degrees to the left. And B is 45 degrees to the right of A. So this information that I've been given here, there's one more piece. Oh, airplane A is 20 units away. So if you look at it, okay, I have angle side side or angle angle side. Either way, it's not side angle side, and it's not side side side. So we go law of sines. So the sine of 50 is to 20, as the sine of 45 is to x. Looking up the values, and it's kind of traditional to write 4 decimal places. You don't have to. You can write the whole thing out on your calculator if you want. Don't only put tenths or hundredths. You need at least 4 places. Cross multiply, 0.8752x equals, and then 0.7071 times 50 is 35.36. Dividing by 0.8752, and I get 40.4. So airplane B is 40.4, what is this, miles from the airport. All right. A surveyor and mountains. It's a little tricky to draw this diagram. So try drawing it on your own, then starting up this video. See if you got the diagram right. If you didn't get the diagram right, then go back, correct it, and then solve the problem. You're going to need 2 steps to solve this question. Okay, so here is the diagram. First, there's a surveyor 1, who measures the angle to be 35 degrees to the peak of the mountain. Then there's surveyor 2, who's 1,200 feet closer, and their angle is 42 degrees. Okay, so that's the diagram that you are looking for. Now, there's some things that can be concluded when looking at this diagram, and the biggie are the measures of these 2 angles. If this is 42, then this is 138 right next to it, right? They're supplementary. And then 138 plus 35 is 173, so that guy's 7 up there. So there's the 138, and there's the 7. And now I can find, it doesn't make a difference which one you want to find. You could find this long piece right here, or you could find this shorter piece here. The 235.3 you don't know yet. That happens to work out to be the answer to that question. And we're going to find this shorter piece right here. And we'll do that using the law of sines. So the sine of 7 will be to 1,200 as the sine of 35 is to, we're going to call it x for now, okay? Sine of 7 is to 1,200 as the sine of 35 is to x. So we don't know this value yet. That's what it's going to work out to be. Find the values, cross multiply, divide by 0.1219, and I get 235.3. So that's where that number comes from. All right. I just put it in the wrong place for animations purposes. Now I can do like SOHCAHTOA here, okay? And I can find the height of the mountain. because for just this triangle here, just the one with the 42 and the mountain and the 235.3, the sine of 42 will be the opposite, which is the height of the mountain, over the hypotenuse, which is 235.3. So sine of 42 is x over 235.3. Look up the sine of 42, it's 0.6691. And then cross multiply or multiply both sides by 235.3. And I get 157.4. So that is the height of the mountain. Okay. Next one up. Go ahead, give it a shot. Okay, so here's our diagram, and notice we're given side, angle, side information. Since it's side, angle, side, we go law of cosines. Y, this opposite side squared, this opposite side from the 6. Y squared is 4 squared plus 1.8 squared minus 2, this guy, that guy, cosine of 6. So y squared is, square them all out, do the arithmetic here. And looking up, of course, the cosine of 6 on the calculator, I get 16 plus 3.24 minus 14.32, which sums to 4.92. And the square root of that is 2.2 miles. Okay? Might have looked a little intimidating when you started, but boy, oh boy, it was pretty simple and straightforward. You could probably notice that I keep calling these sides y because I have this template that I just copy and paste, and then I fill in the numbers as they change for each question. In fact, almost every sloppy mistake I ever make is because I forget to change one of the numbers. So, but in this case, I did change all the numbers, and it's such a regimented, structured way to solve problems that you should be beginning to get a comfort level with said structure. Okay, I think this is the last one. Maybe it's not, but I think it is. Go ahead, try this one. All right, so let's draw the diagram. When we were kids, there was this expression always, Tom, Dick, and Harry. So, T, D, and H. Now, distance between Tom and Harry, that's down here, that's 201. Distance between Dick and Harry is 175. And the other distance is 153. So there's my diagram. Now, what's the angle from Dick to Harry to Tom? This angle here. I'm given side, 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 so I clearly need the law of cosines. Since I want to figure out H, I got to start with the side opposite it, which is the 153. So 153 squared equals 201 squared plus 175 squared minus 2, this guy, that guy, cosine H. And now, danger, danger, danger. Be prepared for this cosine H here to kind of mess things up a little bit. Squared it all out. Start to combine them. And again, here's the mistake that some students will make. Some students will subtract here. You cannot. This is 61,506 cosine H. Unless this first term here, 71,026, also has a cosine H, they cannot be combined. Okay, so instead, I subtract 71,026 from both sides. And that gives me negative 47,617 is going to equal, danger, danger, danger. Don't forget, there's really a negative in front of this 61,506. Negative 61,506 cosine H. Divide by that negative 61,506, and I get that the cosine of H is 0.7742. Now I just do inverse cosine or second cosine on the calculator. H is 39.3 degrees. If for any reason, these questions that you did today are chock full of real life applications of the law of sines, the law of cosines. And I got them, most of these questions, from a pre-calculus course. So this is a nice level of difficulty. You should be able to do it, but I don't think it's going to be easy for everybody to do. If it gives you a hard time, go back and do them again, watch the video again, and you will catch on. I am very confident of that. The happy recap. Two things to really remember from today. SOHCAHTOA. Remember, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. And then, how do you tell when to use the law of sines or the law of cosines? Well, cosines is side angle side or side side side. Everything else, law of sines. Have an awesome day.